Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. We are continuing our control rig series. My name's Kevin, and so far we've talked about a lot of foundational stuff like forward kinematics and inverse kinematics, and today we are going to talk about a very important foundational piece of rigging, which is called constraints. Now, the way constraints work is it's kind of described in the name. We are going to use constraints to constrain one object to follow another object. And there are a lot of different constraints that we can use, which we are going to be going through today to give you some good foundational understanding of how these work. Now, the fortunate thing is once you understand how one set of constraints work, generally speaking, that applies to all of the different constraints, and you will be familiar just because you have an understanding of one. So with that, let's hop into Unreal and take a look at what we're looking at. So here we are in Unreal Engine, and we have a simple control rig for us to work with. Two joints, which we're not even going to worry about, and we have 4 controls. We have our A, B, C, D control. I have specifically made these to be, generally speaking, right angles, squares, diamonds, etc., so that we can see as things move, rotate, and change direction what's happening. Now, as I explained, a constraint allows us to bind one object to follow another object in some way. If we right-click in our event graph or a rig graph and we type the word constraint, you'll notice a whole list of constraints come up. We have aim constraints, parent constraints, position, rotation, and scale. So, as with the description that I gave you already, a constraint will constrain one object to follow another one. So if we're going to do that with a position constraint, we are binding the position of one object to follow another. Rotation of one object to follow another, etc. Now, we're going to start by working with the position constraint. We're going to go through constraint fundamentals using this, and then we'll show you a couple of things to note about some of the other ones once you understand the basics of a constraint. So here we are. We have our position constraint. Now, in this particular case, what we're working with is a child. We're not using bones, we're using controls. And the control that I'm going to make follow is going to be this pink one. All right, that is our D control. So our D control is the child. Now, with all the constraints, generally what you're doing is you're giving it a parent, a pseudo parent. And so down here, once you've set your control, you can go ahead and open up the parent section, and for the first item that we're going to constrain to, we're going to constrain this to another control, and the control we're going to constrain to is this red cube. So that's going to be our A control. Now, when we connect this forward solve up and we compile it, you'll notice that nothing moves. However, when we move our cube now, you'll notice that our D control moves with it, because it is constrained to follow the cube in position. So let's compile that, and let's make one other change here. All right, we're going to take our position constraint, and rather than a position, let's do a rotation constraint. All right, very quickly, we're going to do the exact same thing. We're going to do control. We're going to choose our D control, and we're going to have it constrained to another control, and in this case that is our A control. But this time we're going to do it in rotation. Now you'll notice that when we compile, the D control, the hot pink one in the middle, does not move or rotate. However, when we rotate our A control, the cube, you'll notice that our hot pink control rotates with it. If we compile, we go back to the beginning. Now, what's important to notice is we do not have a position constraint anymore. I can move the A control wherever I want, but the hot pink control, the D control, does not move. It is only constrained rotationally, because that is always all that we have connected. Let's go back to position. Okay, our position constraint makes it so that we can move it around. Now, there are a couple of key features that are important to understand about all constraints. So first things first, there is a checkbox here that says maintain offset. It is checked by default. What that means is when the constraint is created, the offset it has from its parent, it is going to maintain that relative distance so it doesn't move. If we want the pink control to snap to the exact same position as the red box control, we can uncheck this. And when we do so, you'll notice that the pink control snaps to wherever the red box is. Now, in general, so basically to summarize, a constraint has a child, it's called in Unreal Engine, and it has a parent. But you'll notice that the parents are capitalized. Parents is plural, so it could have one or more parents. We'll get to that in a second. And we have our maintain offset box. That's pretty much it. That's all there is to constraints. Now, let's talk a little bit about the fact that this is called parents. We can actually have our D control, the hot pink one, follow more than one control positionally. All I have to do is add a new parent, and in our second parent, I'm going to make this a control, and we could have it follow the B control, which, for example, in this particular case, is the blue sphere. Now, at this point, our D control, the hot pink control, is following both the red and the blue control equally. The weight for each one is 1, and this is the next piece that is common to constraints, the weight. So let's take a look at this. If we move our blue control, you'll notice that the pink one moves, but not quite 100%. Okay, same thing if we move our red control. It moves, but not quite 100%. That is because it's following equally. It's following the red and the blue control equally. If we change the weight of the A control to be 0, it will no longer follow the A control. The weight of the A control constraint is 0. And now, because the weight of the blue control is 1, it is going to follow the blue control 100%. So, our constraints have a child, has one or more parents, has the ability to maintain offset depending on whether or not we want it to or not, and with the number of parents that it has, you can choose to set the weight accordingly. Now, here's the interesting thing. We now have 2 parents. Let's set our weight to be equal. If we do not maintain offset and we have 2 parents in a positional constraint and we don't maintain our offset, this is going to snap to position to be halfway, in this case, between the red and the blue control. The reason for that is the constraint is weighted equally to both the red and the blue. If I change the red control to be half the weight, you'll notice that the hot pink control moves to be closer to the blue control. That is because the weight of the blue control is more, it's greater, it's 1, and the weight of the red control is half. So depending on what your weights are set to, that will determine how much this pink control follows either the red or the blue. Once again, if we maintain our offset, it is going to go back to where it is, and it's going to follow based on the weighting that is here. That is it. Okay? Constraints are very straightforward. We're having a child follow a parent, and we can do it positionally, we can do it in rotation, we can do it in scale. Now, there's a couple other things. Now that we have this information, let's go ahead and do this exact same thing except with a rotation constraint. So let's create a rotation constraint. We'll type constraint, and we're going to set up the exact same behaviors. Let's just disconnect position for now, and let's get our control, and we're going to make this our D control just like we did before. We're going to make our first parent be the control and the A control, and then let's go ahead and create a second parent, and this is going to be the B control. Okay, when we compile that, the pink control does not move because we are maintaining the offset. However, when we rotate our A control, you'll notice that the pink control rotates a little bit, not 100%, but a little bit. I'm also going to turn off my snapping. Now, if we rotate, and it's the same thing if we rotate the blue control, you'll notice that it gets a little bit of it. However, just like with the positional constraint, if we set the weight of the A control to be 0, now when we rotate the A control, you'll notice the pink control does not move. However, when we rotate the blue one, the pink control works with it 100% just because we set the weights. Now, what's interesting about the rotations is when we uncheck maintain offset, you'll notice that it did not move. The reason that it did not move is because the blue controls default rotations are 0. The red controls default rotations are 0, and so is the pink. So it's not going to change. However, if there were a rotational difference, it would, just like the point constraint, snap to be halfway between or whatever the weighting happened to be. So that is how we would set up a rotational constraint, and we can combine them. So let's go ahead and combine these. So we have our weight of 1, and we're constraining red to blue. Let's do this and compile it. We've maintained our offsets. So now the pink control follows the red and the blue control in both position and rotation by 50%. Or actually, we need to up this weight. 50% each, because the weights are equal across all. So when we move this, you'll notice that it moves 50% with red. When we rotate this, it rotates 50% with red. Same thing with blue. When we rotate 50%, and so on. So almost all of our constraints work exactly the same. So let's take this and delete this now, and let's take a look at a couple of other constraints that are worth mentioning. Constraints, and we're not even going to cover the scale constraint. It works just like position and rotation, but there is an interesting one, the parent constraint. The parent constraint has all of the same features and aspects of the rotation and the translation combined. So we can use one constraint to do both of those things. So in this particular case, let's change this to control, and we're going to be using our hot pink control, and our first parent is going to be our, well, it's actually even more interesting than that. Hold on, let me show you the difference. We're going to do, and actually I'm going to undo because I want to show you the exact difference. Give me 1 second. I want to bring back my, okay. We're going to bring this back, and let's just do one item for the purpose of this test. All right, and we are going to all right, let's just trash all this stuff. Trash all this. Parents are 0. Okay, so for this one, the D control, let's add in a parent, and the item is going to be the A control, and the A control, and same thing over here. Let's add the parent, and it's going to be the A control A. Okay, so we've reestablished our constraints for rotation and position. We're maintaining our offset, and we're only constrained to this A control. Remember, movement works, our translation works, but our rotation is a local rotation. Notice how this rotates about its own center axis. I want to contrast that against a parent constraint. A parent constraint, effectively, it's almost like a dummy parent. It's almost like we're parenting it without actually physically changing the hierarchy. So what this is going to do is, if we use a parent constraint on our D control to our control for A, what we're going to end up with, just like the other constraint attributes, if we maintain our offset, when we compile this, what we get is we can translate our A control, and our red control and our hot pink control goes with it. But now when we rotate, what you'll notice is it rotates around the pivot of the red control, because it is basically a pseudo-temporary parent. That is slightly different than the way a rotation position constraint works, because the rotation is just relative to its own transform, whereas the parent constraint is almost like parenting to the other object without actually changing the hierarchy. So that's one big difference to highlight about the parent constraint. In general, we love these kinds of constraints, and we'll use them frequently and often to temporarily give controls the ability to follow another object in both rotation and position, but maintain the offsets and act as if they have a new parent. So that covers our translation, rotation, and parent constraints. All of our constraints sharing generally the same attributes. One last one to take a look at, just because it is slightly different, is our aim constraint. Now, just as we did before, we're going to go ahead and do a control, and our control that we're going to constrain is our D control. This is why I picked a pointy object for the D control because I want you to be able to see. Our constraint, for an aim constraint, what we are telling the child is, I want you to look at whatever I tell you to. And I want you to, and the way we describe how you aim at the object I want you to follow is by giving you information about which axis. So in this particular case, you'll notice that my aim axis is set to x of 1, y 0, 0. X points down towards the right in this viewport, so it's towards the sharp pointy end over here on the right. Our up axis is important. The up axis in Unreal in this case is Z up. Now, there are different options that you can use for the up. I'll explain to you why we do that in a second, but first let's get to the constraint. All right, and now we have our target, and we can use a target position that is something that maybe changes over time, or we can use a control. Now, in this particular case, I'm going to use a control, and the control I'm going to use is my A control. And when we compile that, you'll notice that everything snaps back to where it was, right? By default, when we connect this, everything snaps to where it was. But now we are constrained so that the pink control will always aim at wherever the red control goes. Okay? Now we can also change this. If we were to aim this pink control rather than at the A control, we were to aim it at the B control, you'll notice that it'll basically, it won't change direction. And the reason it's not changing direction is because we have this maintain offset here. If we don't maintain the offset, you'll notice that it will rotate to snap to face the blue control. And then it behaves just like as if it was facing the red control. So if we go back to our A control, which is the red one, and we don't have maintain offset, nothing changes. The reason being is because the red control is already perfectly aligned with the current facing of the pink control. So that's why there's no change. Now, let's talk about one other thing that is important to understand about aim constraints, and that is the world up. Now, the up direction, what you can think of is, here, let me help you out, visualize this here a little bit. What you can do is you can think of the up direction as, for example, this object that sits above the pink control. And I'm going to set the offset from current. Okay, and the reason that we're doing this is, if you think about it, this control, if the red control were to pass over it, the math can get funky. We don't worry about the math, we just worry about the creative. But I'm just letting you know, math can get funky, and what can happen is the constraint can get confused and it can flip. So we give it an up vector to help stabilize. However, the up vector is important. If we pick an up vector that, for example, let's see if we can get this to flip out. So our target is a control, and let's see if we can give it the C control. And if that's the case, location, yeah, you can see how it moves when I move my up vector. So that affects the roll, pitch, and it affects the roll right now is what we're on. All right, and so what's going to happen is, if we were to, and this may be difficult to see and we may not be able to do it, if we get the, you can see it. So as this red control comes up and starts to cross over where our up vectors, you'll notice that the hot pink one starts to flip. So it gets confused because there's limitations in math. And so we use these up vectors to help stabilize that. And so what we might do in this case is, you can think of it as, this up vector might be parented to a different object, or it could be in a different rotational space. So that, as for a great example might be, if we were to, well, let's just, as we move this up and over, if we move our up vector as well, you'll notice that the pink control stabilizes. So now that this up vector has been moved, apologies, this will now stay stable in this range. It will stay stable until we start to cross over the yellow control, because that's where the axes come together, and then it gets confused. It doesn't know what to do. So it's important to understand what the up vector is It determines which way is up for controlling the roll, and depending on where it is and how it's moving relative to your aim constraint, you can get some kind of flipping if it's not done quite correctly. I thought that was worth potentially mentioning. So let's take a quick look back through, see if there's any constraints that we missed, and we did not. So with that is a brief but thorough introduction to the foundational understanding of what a constraint is. We're going to constrain one object to follow one or more other parent objects. And we can do that with all of the constraints share many of the same attributes. They all have potentially one or more parents. They all have weights. They all have the ability to maintain the offsets. And we are going to be using these constraints all throughout our control rig series, so it's important that you understand what they are and how they work. As always, thanks for checking out the channel. If you dig what we're working on, help spread the word, let people know what we're all about. Thank you for everybody for being the best part of this channel, which is our community. We have Patreon, Discord. Don't forget to hop into Discord. We have tons of people asking questions, helping each other out. That's great. Also, very important, a huge portion of our tutorials are in the live section because we have just about the right amount of crazy to do some of these live. So don't forget to check those out. Those are there for you to hopefully help you wreck the learning curve. My name's Kevin. We'll see you in our next control rig tutorial. Take it easy.